I read with interest as everyone had their different arguments. Some people added some different sort of language on it, like the idea of number density, numbers packed together really close. I thought that was a very clever way to do it. Okay. Here's how I think most people argued. I'm going to put this on a number line. Okay, illustrate it like this. Okay, so if you've got some integers like this, okay, you're like, look, I can go ahead and I can count all of these up, right? But then you would say to me, hold on. If I'm trying to do this whole pairing business, right? If I'm trying to approach it that way, look, you match one natural number with some rational number, but hold on. These are all rational numbers themselves, right? So you're like, this guy is matched up with a rational number, namely itself. This guy's matched up with a rational number, namely himself, and you keep going, right? And then you've got all of these leftovers, right? So you've got all these guys. Okay? Right? And I can keep on doing this forever. And if you want to follow that kind of argument, you can say, well, hold on a second. If there's an infinite number of integers, or natural numbers, okay? But we can also say, surely between 0 and 1, there's an infinite number of fractions, right? So therefore, you could kind of argue this size is infinity, and then this one would be like infinity times infinity. Because for every one of these, every pair of numbers, you've got an infinity in between there. My brain hurts already, okay? Well, guess what? If we think about this diagonally, I can show you actually it's not the case. The problem is how we set it up. This is how I laid out the natural numbers, okay? But we can lay that out in another way. In fact, let's draw all of the rational numbers, okay? Listing out the rational numbers. So here's my sum. Now you're like, well, this will take a long time, right? But it depends on how you do it. Okay? For instance, if I write this, okay? This is a nice logical way of laying out the natural numbers. So you can see, I haven't missed any, right? And if I just keep on going and I follow the pattern, I'll get them all. I'll catch them all. Is that all right? Question?
Do you need the 0?
Yeah. Well, strictly speaking, I need these as well.
Yeah.
It goes in both directions. But you'll see it won't matter if I go both directions or not. Now, here's my question to you. And I'll give you a second to think about it on your own or in a pair. If this is how you lay out the integers and don't miss any, how would you lay out the rational numbers in such a way that you make sure you don't miss any? Now, I'm going to let you try, okay? I'll give you a clue. This way, forever, it's not going to cut it. Because clearly, I'm missing a lot of fractions, right? In fact, I'm missing an infinite number of fractions between here and here, and here, and this is not going to work, okay? So can you lay out the rational numbers in some other way so I know when I look at your list and I see there's a dot, 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 a dot, 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 that you've got all of them? I'll give you a couple of minutes to have a think about how you might do this, okay? Because it's key to how we show the point. The point is, if I can lay these all out in some kind of logical sequence, then I can start to do this. I can start to match things, and then I can see if this will work out. So here's the way I'm going to do it. Some more space. Okay? And here's the way you can write all of the rational numbers. It's really not that hard. Okay? What we're going to start with is where we began with the number line. Okay? So for instance, if I have 1 over 1, I'm not going to worry about 0 because you'll see this argument will continue to apply if I have 0. If I have negative numbers, it'll work out. I'm going to write out all the numbers with denominator 1. Is that okay? So I'm going to have 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1. No big deal. And this will go on forever. Okay, so far so good. But you're like, missing a lot of numbers. That's true. I don't have any with denominator 2, for instance. But that's okay. I can write those in. I'll have 1 over 2. I'll have 2 over 2. Don't worry, I've already got him, but that's okay. I'll have 3 over 2. 4 over 2. Okay, now hold on. Not there yet. Not there yet. Now, just leave aside for a second the fact that I've got repeats here. Okay, you can see this is a repeat with this, and this is a repeat with this, but guess what? It's going to work anyway. Now, I'm still missing fractions, right? What fractions am I missing? All of Denominator 3. I've got this one already. Denominator 4. Well, you know what? I'm just going to say ... Right? I'm doing the same thing this way as I am this way. Can you see? Horizontally, I'm changing the numerators. Vertically, I'm changing the denominators, right? So you're used to, in coordinate geometry, they say, this is the x-axis, and this is the y-axis, and you're used to people telling you, just have these axes, because I said so, okay? Well, guess what? You can define whatever axis you like, whatever is useful to you. This is the numerator axis, right? Changing the numerators. And this is the denominator axis, okay? Now, what I'm trying to do, I'm trying to do this thing, I'm trying to pair up. Now you will see, if I start over here and say go this way, I'm stuck, right? I have my big pile of integers, natural numbers, and negative natural numbers, right? And I start walking this way, and I walk forever, and I never get to the end. And this was your argument before. You said, look, you missed all of these numbers. So I think, okay, well, how about if I go down this way? What if I go down this way, and I keep walking down? I'm still going to run out of numbers, right? I'm going to go all the way down here and I will never have touched any of these. Unless I go diagonally. So here's what I'm going to do. I'm going to start here, because that looks like a good place to start. Okay? And then instead of going that way or that way, I'm going to go, well, let's come around this way, like so, and then I'll go here, and then here in a diagonal. So now I've covered all these. And now I'm going to come back around like this. Like so. Okay. And here's the thing, right? You're like, well, you'll never get to the end. But that's okay. I have a bag that is bottomless. I'll always be able to pull out more integers, right? And I'm never going to miss one. That was the problem you gave me before, right? If I go down this way, you're like, oh, you've missed all these and never touched them. Or if I go across this way, I'll miss all these and never touch these, right? But if I go in a diagonal, there's never going to be one missed out. I'm going to get to every single one. I'm going to pair up every one of these with one of these. Every rational number is going to get covered. Does that make sense? So here's the result that comes out of this, okay? If you've got the integers, right, and you say, well, what's the size of the integers, right? Well, like that crazy mass of primary school kids, I don't know how many there are, but I can match them all up with the rational numbers. So that means the size of those sets, the sizes of those sets, they're both the same. They're both equal because I can match them all up. Yes, that's right. Let me take that idea a little further, okay? Let's consider, and I wonder if you can anticipate the argument before I give it to you. Okay? Let's consider the set of, well, let's call this one just the natural numbers. Okay? And then let's consider all of the even numbers. Now, which do you think there would be more of? Right? Now, if you think from a density point of view, right, you're like, well, clearly there are more natural numbers, right? Because the even numbers are spaced out, right? Oh, but guess what? I can match these guys up. Easily I can match them up. Watch this, right? Here are all of the natural numbers, right? And here are all the even numbers. I can match them up like this. Look, 1 I'll match with its double. 2 I'll match up with its double. 3, am I ever going to miss any?
No, because they go for...
I'm not. This one's going to go forever. This one's going to go forever. And I haven't missed, there are no gaps. I've caught them all, right? And there's way more than, actually I was going to say 151, but there's not that many Pokemon anymore. There's many more. So I can catch them all. There are none missed. Just like with the diagonal, right? I'm marching through it, and sure it'll take me forever. But that's okay. I've got an infinite number of things to put matching to matching, right? They're all going to match up.